All right, so in this video we're going to talk about division in modular arithmetic. All right, we kind of skirted over this one in the original video on modular arithmetic, so we're going to go into it a little bit deeper here. So first, we actually need to introduce something that seems unrelated, which is the idea of relatively prime. So two numbers are called relatively prime if they share no common factors. All right, so we all know how to factor numbers. And so if when you factor the two numbers, they don't have any factors in common, then they're considered, well, relatively prime. So for example, we're going to do a lot of 26 stuff since that's kind of the number we use the most in this class. 3 and 26. All right, so are those relatively prime? Well, the only factors inside of 3 are 1 and 3. It is prime. 26, well, we can write that as 2 times 13. All right, so the factors in 26 are going to be 2 and 13. All right, well, neither of those are 3, so yes. Okay, let's make this colorful. Yes. All right, 3 and 26 are relatively prime. What about 10 and 26? Well, 10 has 2 in it, right? 2 is a factor of 10, and 2 is a factor of 26. So, no, those are not relatively prime. All right, so one more. Let's say 15 and 26. All right, 15 is not a prime number, but it is relatively prime to 26 because the only factors in 15 are 5 and 3, all right? Neither of which is 2 and 13. All right, so they don't share any of the same factors, so 15 and 26 are relatively prime. All right, so now we're going to get into the real meat of division. So a number n mod 26. All right, so we're talking about one of those numbers 0 up to 25. We call that a unit. All right, kind of a strange word. If we can find a number a mod 26, so another number between 0 and 25, such that a times n is equal to 1, mod 26. All right, so a number n is called a unit if there's something I can multiply by it so that I end up getting 1. All right, so in the normal number system, pretty much everything is a unit except for 0. Because, say 3. 3 is a unit because I have 1/3. All right, I can multiply 3 by 1/3 and I end up getting 1. 121 is a unit because I can multiply that by 1 over 121 and get 1. However, in modular arithmetic, it's not quite that nice. So let's look at some examples of units. All right, so 3 is in fact a unit. All right, there is another number, mod 26, that I can multiply by 3 and end up with 1. All right, in particular, that number is 9. All right, because 3 times 9, mod 26, that's the same thing as 27 mod 26, and 27 mod 26 is 1. All right, so both 3 and 9 are units, mod 26. all right, because this is really interchangeable, all right? I can multiply 3 by 9 to get 1, and I can multiply 9 by 3 to get 1. So both 3 and 9 are going to act as units. All right, here's another example, 11. All right, 11 we're going to see is a unit because I can multiply 11 by 19 mod 26. All right, what I get is 209 mod 26. All right, the nearest multiple of 26 there, all right, we'll just kind of put this in parentheses down here. All right, so 208 is a multiple of 26. All right, so 26 times 8 will give me 208. 209, so 209 is one above a multiple of 26. It's one above 208, so this is just going to be 1 mod 26. So both 11 and 19 are units, mod 26. All right, and so this whole mod 26 thing that I keep saying is really important because 3 is not a unit, mod 3. All right, so if I'm using a different modulo, that's what we call this 26 number that we keep on using, the units change. All right, and we're going to see why in just a sec. But we are really going to focus on mod 26 because we're just going to keep our alphabet the same throughout this class. But I just want to make sure that's clear to you. All right, and so what's really happening here is, let's take a look at this example right here. 3 acts like 1/9 in mod 26, and 9 acts like 1/3 in mod 26. All right, and taking a look at this bit right here, 11 acts like 1/19, and 19 acts like 1/11, all right? The only numbers that exist are 0 to 25, but there is sort of an equivalent to 1/9 in there, and that is the number 3. All right, in the same way that there's an equivalent to 27, and that's the number 1. There's equivalent to -1, and that is the number 25. So all the numbers in the real line are sort of represented here. The caveat to that is there is no 1/2. Right? Or 1/10, or 1/8, or 1/4, or 1/13. All right, so not every number is a unit, and so not every fraction kind of exists in modular arithmetic. So this is all way more complicated than we're really going to get into. But what I want to recognize is the fact that some numbers in mod 26 basically have an inverse to them. All right, they have a reciprocal that's represented there. And how do you know which ones do and which ones don't? How do you know which ones are units and which ones are not? So we have this beautiful theorem. Theorem is just fancy word for a true fact. If n is relatively prime to 26, then n is a unit, mod 26. So this is how we figure out our units. We simply ask, okay, is this number relatively prime to 26? And so this is why 1/2 is not going to exist, because 2 can't be a unit because 2 is not relatively prime to 26. And the same with 1/8 and 1/10 and 1/13 and 1/4. All right, none of these are relative. The reciprocal, the denominator is not relatively prime to 26, and therefore 2 and 10 and 8 and 4 and 13 are not units. Okay, so we've gone through a lot of this to try and talk about what may seem like some esoteric mathematics. And this is not a higher level math course, so why am I teaching you all this crap? Let's get into that. All right, because having a unit, basically being able to have a reciprocal of a number, is something that you use all the time in algebra. All right, the fact that 3 is a unit allows us to solve equations like 3x plus 9 is equal to 11, mod 26. All right, we saw some examples in the last activity where you can't just cancel out both sides. That doesn't necessarily work. But what we can do is multiply by 1/3 ish on both sides. So let's work through that. All right, so we can subtract on both sides. All right, that's not a problem. So we can take this 9 and move it over, just subtract 9 from both sides. So we get 3x is equal to 11 minus 9 mod 26. Well, that's still just 2, right? Don't have to do any fancy magic there. Okay, and so now we want to divide by 3, but yeah, we're not allowed to just do that. But what we can do is we can make the 3 go away if we multiply both sides by 9. All right, because we know that 9 times 3, that's just 1. All right, so then it'll just kind of disappear. All right, so we could write 1 times x, but we never do that because we're lazy. So this tells us that x is going to be 9 times 2 mod 26. Well, that's just 18. Right? The mod 26 doesn't really do anything. So given this algebraic equation, we can solve it and figure out what x is going to be. And of course, we can then check. All right, we could take this and plug it in for x. 3 times 18 plus 9. Okay, so what is that going to be? All right, mod 26. All right, so 3 times 18. That's going to give me 54 plus 9, mod 26. All right, 54 plus 9 gives me 63, mod 26. All right, the nearest multiple of 26 is going to be 52. So how far away is 63 from 52? All right, well, you can just do 63 minus 52. That's 11. That's exactly what we want it to be. Okay? And so this allows us, the fact that we have units allows us to solve algebraic equations. And that's going to be something that we use later on. All right, so next we're going to talk about a different type of cipher that uses multiplication. All right, and so this is going to start to be useful.